Now, there's some additional information that we should know about imines. There are a lot of reagents that can be used to make imines. For instance, let's use our quick product method that we learned to figure out the products of these two reactions. And let's start with the top one. Again, in this case right here, the OH group is going to be the R group that's attached to the amine. So our quick product method would say the C double bonded to the O is now C double bonded to the N, and he still has his R group attached, and again, that's the OH. This particular compound is called an oxime. Let's now figure out the product of the bottom reaction. Notice this one has two NH2 groups. So it's symmetrical here, so it doesn't really matter which side you want to call your R group, but let's say this is the R group attached. Then our product is the C is now double bonded to the nitrogen, and he retains his R group, and again, in that case, it's NH2. This molecule happens to be called a hydrazone. These products are called imine derivatives. And one use for these derivatives is to help us determine if we have an unknown molecule and we want to know if it has a ketone or an aldehyde. If the molecule does have a ketone or aldehyde, it will react with these reagents and produce these imine derivatives. And it just so happens that some of these derivatives happen to have bright colors. So when you run these reactions, the bright colors make for a very great way of determining that you do have an aldehyde or ketone. But let's look at another example to make sure you got this. Sometimes they can be a lot more complicated, like this molecule. In this particular case, your R group would have to be this huge part right here. And to get this thing to quick product here, we're going to take our C, double bond it to the oxygen, and doubly bond it to the nitrogen and retain that R group. This particular imine derivative is a 2,4-dinitryl-phenyl hydrazone. So all that's important here is that we know how to determine a quick product for any of these derivatives and know that they're necessary to identify if an unknown molecule has an aldehyde or ketone. However, there are additional uses for imines, and a very popular one is called the Wolff-Kishner reduction. In this reaction, we're using hydrazine, some OH minus base, and heat. And let's look at the overall reaction first here. Notice all this reaction does is turn a C double bond O into simply a CH2. We could think of this reaction as simply wiping out the carbonyl and reducing it down to a CH2 group. In fact, let's learn our quick product method first. Let's look at this sample problem. Provide the necessary reagents. Your thought process would be, well, that's a ketone there, cyclohexanone. We're reacting NH2, which is hydrazine, but with base and heat, that makes you think Wolff-Kishner reduction. So that means you're going to wipe out that carbonyl and turn him simply into a CH2. So our product is simply cyclohexane. But let's make sure we know that this reaction is very specific. Meaning this, look at this problem. Provide the necessary reagents for this reaction. The product for this one would actually be this molecule right here. And here's what we need to know. The Wolff-Kishner reduction only works on ketones and aldehydes. It does not work on esters. So that's why the ketone was wiped out in this molecule and the ester, notice, remains.